Hi, so today I will show how to find plagiarism on documents. This was the assignment given to us by the data analytics course 1 I am following. Before dive into the code, let's look into what TF-IDF is. TF-IDF means word stands for term frequency inverse document frequency. What is meant is it calculates weights for words, how they frequently appear in documents. Uh, when you read it, there are two terms. Term frequency, where we see how often a word appear in a document, and inverse document frequency for how the word appears in multiple documents, corpus. Uh, and we calculate TF-IDF to vectorize and get an overall idea. When it comes to detecting plagiarism, we can implement a method using this TF-IDF. In this approach, I am mainly using two methods. One is to calculate TF-IDF in all the documents provided for us in this assignment, and after that I use a similarity score to calculate which documents are mostly equal to the provided query document, the one we are trying to find whether it is plagiarized or not. Let's dive into the code. Here first I will import the documents provided to us because colab cannot keep documents truly. If we add documents for a while, when we log back again, since it will change the virtual machine we are using, the documents will be gone. So first what I do is I am importing this Google Colab drive. I'm mounting it, mounting my drive, and to read files, here I am specifying where is my document. It is in here, this folder, homework assignment. So I am attaching those documents to variables using a file descriptor by providing the paths and the mode, and I'm open the query, then I'm reading that and assigning to variables so that I can use it later. So that's part done. Now I have the documents. Next part, I'll use scalar library to find out the plagiarism. I use this because we already tried the implementation from scratch in the tutorial session. So thought of exploring this libraries more. In this, to find TF-IDF, I am using a function called TF-IDF vectorizer. This vectorizer is equal to counter vectorizer and TF-IDF transform. I mention it here. This count vectorizer is used to convert a collection of text documents to a matrix of token count, and TF-IDF transformer is handling the transform matrix to a normalized TF-IDF representation. So both those operations are happening from TF-IDF vectorize. Here I added some document to read. This is regarding whether to remove stop words or not from a document. We will get into it. So in the first step, I am importing the TF-IDF vectorizer from scalar speech extraction text. In this part, let's run this. Yeah, it's running. This part I am trying to get a set of stop words from the NTLK type. I print the first 10 words, but first let's look at without any parameters for the TF-IDF vectorizer. I've gone to the documents provided in the lab session, but though this TF-IDF vectorizer has several parameters, like we can exclude stop words with it, and there are parameters to whether to lowercase the words, we feed it to it. By default, it lower all the fonts. So let's go the steps. In the next step, I am doing a pit transform to all the documents and the query, and since I need this TF-IDF value in a later step, I am getting the TF-IDF value of the query. Here I am printing the shape because I just wanted to check how many words get subtracted if I use the stop words with this. But I didn't use the stop words in this assignment because the research I attach here shows that the plagiarism detection need these stop words to get a good idea and get a clear idea on whether the documents are matched or not. So I thought of the best way is to exclude the stop words, not to exclude the stop words. So here I am extracting the page names, those words, and just printing out to check scores and the words. And since it's hard, I also printed it as a data frame using the pandas. Here, since then, now we have a vectorized version of all the documents, and now we need to find similar documents. So when it comes to finding similarity, in the lecture also we have identified several methods like calculating Euclidean distance, Manhattan distance, cosine similarity. But this study, I just check whether what is the similarity. So we don't know what's the best for plagiarism detection. This kind of works. After checking that, I found that cosine similarity has a much effect when coming to the plagiarism detection. So I use it here. Cosine similarity contain values between 0 and 1. It is assign 1 if match perfectly, and it assign a value between 0 and 1 if match for some extent. So here I imported that cosine similarity from a scalar and metric pairwise. Here I just put the trying to check the similarity between each document. If we consider this as a matrix, this row has this matrix represent and compare each document. Here the first document is the first document. Since those documents are similar, it gives a 1. Those are similar. First document is second document, and so on. Since I need to check the response against the query, since I previously got the query value, here you can see that query is much similar to this one. This is the second document because I included them in order. This is 1, 2, 3, 4, 5 and the query one. This is exactly same as the query, so it gives 1, and beside that the most closer one is the second document. So that's pretty much it for my flow. Let me show you what happens if we use stop words. So using stop words reduces some amounts of words. The most common ones like the, then, like us. So if we print again the cosine similarity, now it has the same score, but it reduces a little bit. So that's, and the research, because of research I thought of not using excluding stoppers. So that's pretty much it for the assignment, and you can find this collab link from the YouTube description, and thank you.